Hello everybody, and today we're going to talk about Quaoar. Can you just the one thing I want to tell before we talk about things, the few things I want to tell is about please accept my hard work. I have been working on this for months, and it's a lot of pressure I have been working on this every day. You won't imagine. It took remember I said months. It's a lot of time. And finally, I'm back to say my video. So please accept my hard work. And the second thing I want to say is, when we're talking about Quaoar, right? There's gonna be questions in the middle, right? So for example, question 1, question 2, question 3. So there are gonna be questions and numbers. If someone does not know something, then the questions are here. So the first thing we're gonna talk about is so what type of thing Quaoar is? What type of object? So Quaoar is a dwarf planet candidate. So a dwarf planet candidate is it is a smaller than a dwarf planet. For example, so the dwarf planets, the 5 dwarf planets like Maki, Eris, Pluto, Sirius, Haumea. Those are the 5 dwarf planets. Then a dwarf planet candidate is smaller than that. So that's called a dwarf planet candidate. And also, there should be 3 rules or laws for a dwarf planet candidate. The first law is it has to have enough mass to be round. So that means it should be round at all certain times. The second thing is it cannot be a moon. So that means it cannot orbit a planet. It has to orbit the sun, because moons orbits planet. So it cannot. So since dwarf planet candidates are not planets, they don't orbit like the moon does. So they orbit the sun. Then the third thing is the dwarf planet candidate cannot be broken from other space debris, such as, for example, comets, asteroids, and all those stuff. So the discovery date of a Quaoar is June 4th, 2002. So 20 years back, where we are from now, around 20 years back. So it's a long time, even before I was born. That's when they discovered it. But there's still some things out in the solar system. For example, you have to discover a recent discovery they just discovered is Quaoar. Quaoar's rings. So it was discovered this year. So I might talk about in the next video or in the next to next video. So it was discovered this year. So that's why I made a video about Quaoar. That's the reason why. So its discovery was Chad Trujillo and Michael Brown. And they too, the 2 astronauts, 2 astronomers, right? So there are 2 astronomer names that discovered Quaoar. So there are American astronauts, and the location of Quaoar, right? It's in the Kuiper Belt. So the meaning of Kuiper Belt, the Kuiper Belt's meaning is it is farther. The Kuiper Belt is farther than Neptune. It's a place where I see comets live like asteroids, dwarf-like candidates, dwarf planets. They're all are Neptune. All are beyond Neptune, or the Kuiper belt. So, the observatory name, right? Observatory name, right? I mean. So let me just tell you the meaning of observatory. So the meaning of observatory is that wait, I just want to tell something, okay? Wait. So the question one, so I said like the questions part, right? So I said to you like, what's the dwarf-like candidate? That is question one, okay? So now we're about to go on to question two, okay? So its observatory name is Palomar Observatory. So I mean basically, an observatory is where telescopes are, like where a few telescopes are, such as there is the Samuel like, for example, there's a Samuel Austin telescope that the astronomers discovered. It's in the Palomar Observatory. So an observatory has a few telescopes. So the telescope I just said now, the Samuel Austin telescope, was the telescope that they discovered. So that's the name of it. So, okay. So another thing I want to tell about the telescope is its height. So its height is 48 inches. And now we're gonna go on to the second question. So, So the diameter of Quaoar is 1,086 kilometers, or km. Its radius is 543 kilometers. Then next I'm going to talk about is question 2. So question 2 is what does radius and diameter on a sphere mean? So for example, this is a sphere. And this is a dot, right? Like a dot in the middle, right? So the sphere, right? So the thing that's going so there's a line that's going on the whole sphere. That's called the diameter. Diameter is it's called the diameter. So diameter is the whole size of the sphere. So you may not think that the dot is important, but it's actually important, right? So there's another thing called radius, right? So you see the dot which I have? The dot? So on one side of the dot is a radius, and the other side of the dot is another radius. Basically, you can say that so two radiuses are one diameter, and one diameter are two radiuses. So yeah, I'm gonna tell this one more time. So one side of the circle, like the dot, separates the two parts. So one part is radius and the other part is radius. So now let's do some math, okay? It's math time. So, pretend that 1,086 is the diameter of Quaoar, or the whole size of the size of Quaoar. So if you were to divide it by 2, then they'll get the radius. And the radius is 543 kilometers. Because 1,086 divided by 2 is 543 kilometers. just for me. We're just turning the page. So question 2 was all finished. So now we're going to talk about how much years to orbit the sun. It is about 285 to 286 years that Quaoar is orbiting. That is one revolution of the sun, or one whole orbit. This is kind of interesting, but what's the location of Quaoar's discovery? It's a lot of things. It's the exact thing. When I mean a lot of things, it's the exact thing. So, its discovery was a 35,899 Canefield Road, Palmore Mountain, Southern California, 92060. So I said 92060, right? That's its zip code. And did you know that? The Palmore Observatory is 20 to 30 miles away from San Francisco, a city in California. Also in Southern California, the observatory. So it has a second name. So the second name is 50,000 Quaoar. It's his second name. 50,000 Quaoar. That's the second name. Then it's not like one of those two names that we're talking about. It's called a designation now. So now the next part is called a designation after the second name. So its designation is 2002 LM60. I don't know what does LM60 stand for. I tried to Google, but it did not show up. But I think I know what does 2002 stand for. I think it stands for the discovery because Quaoar was discovered in 2002. Now, this is kind of interesting. How much kilometers from Earth is Quaoar? You may think it's a lot. It'll take many years to reach there. It's a lot that it's a lot of years just. So the answer is 6 billion years. 6 billion years. A lot of years to reach to Quaoar. It's very far. I'm telling you. Now we're going to move on to our third question, or question 3. So question 3 is what is a kilometer? So I think you may have mentioned. I think I have mentioned like it many times, like mostly in question 2. So the meaning of it is it's a unit of measurement that is equal to 1,000 meters or 0.62 miles. By me saying that, I know that a mile is bigger than a kilometer. So 0.62 miles is 1 kilometer. It's not even a mile. So a kilometer is smaller than a mile. Now this is another shocking thing. Years to go to Quaoar. How much years it'll take to go to Earth to Quaoar? So pretend this is Earth, and pretend this is Quaoar, right? So Earth to Quaoar will take to go 100,000 years, a lot of years. Even you may die after those many years. You may feel tired, you may feel sleepy, you'll miss everybody from planet Earth. That's why don't go far. Like, don't go to a far planet. It'll be very cold out there, and you might die because and you may not survive because of cold. So the things that Quaoar has on its surface, right? So it has on its surface a small amount of methane. Ah, that's remembering me of something. So remember, I told the meaning of methane, right? So the meaning of methane is a person's or animal's death, decomposition, or wait, what's the third thing? Or an animal or human poop, which is very disgusting. So now that's the first thing that Quaoar has on its surface. Then it has ammonia hydrate, crystalline ice, carbon monoxide, and nitrogen. It has 5 main important things. So, since you don't know about it, I'm going to tell you. Now, what is the meaning of ammonia hydrate? So, it is a type of colorless liquid. I mean by colorless, like it does not have any color at all, which is kind of sad. And it has a strong smell. It has a strong, very bad smell. So don't smell this next time. So if you see that, don't smell it, or else something will happen to you very bad. Trouble. So don't smell it. I'm giving you a warning. So, question 5. What is crystalline ice? The meaning is ice in a crystal material happens when the ice molecules turn into a cubic or hexagonal shape. I mean that's question yeah. So question 6. What is carbon monoxide? So it's a poisonable gas. Wait, just for a minute. Wait just for a minute. I'm very sorry, okay? A question, right? I'm just going to say a question now because I'm just tired of saying all those numbers. So I'm just going to say a question, okay? So the question is, what is carbon monoxide? The meaning of carbon monoxide is it's a poisonable gas. That means don't touch it. It'll affect your health very bad. So, it's also a gas that is colorless and does not smell good and tasteless. That means you cannot taste it, and it's colorless. So carbon monoxide has 1 carbon atom and 1 oxygen atom. So this is 1 carbon atom and 1 oxygen atom. If you do like this, that is carbon. What is it? Carbon monoxide. So if you if you make one carbon atom and 1 oxygen, and if you smash it together, it'll be carbon monoxide. I just want to tell you that in any gas, someone discovers some gas, right? That's why we know about it. So I think the discovery of carbon monoxide is actually very old. It was like in the 17th or 17th to 18th centuries. And it was discovered by Joseph Priestley. He was maybe an American or a British, I don't know. But in my opinion, I'm just saying it's in my opinion, okay? In my opinion, he may be a British or he may be an American. So we can like say that this is the era of questions. Like there are many questions in between. So the thing I said, it should be question 5 or 6. No, actually, yeah, it should be question 5 or 6. The carbon monoxide said it should be question 5 or 6. So now there's another question. What's the atom nitrogen? So it has the symbol N. So in every atom has a symbol letter, and its symbol letter is N. Its atomic number is 7. What we're going to talk about in question, in the question after. It's an atom that's very suitable for life. That means it's very good for life. It's very amazing, excellent for life. Basically, you can say. And it was discovered by Daniel Rutherford in 1772. So the same thing I said, right? He may be American. That's my first option, or he may be British. That's my second option. It's the same thing I'm gonna say. And now remember, I said what is a. Remember I said what is a like the atomic number is 7. So now we're gonna talk about what is atomic mass and number. And just one more thing for a question. For the question I said before. For the nitrogen question. So, its atomic mass is 14 or 1/4. Wait just for a minute. Questions. So another question I will tell you is, what is atomic mass and number? This is very long, okay? So everything should have a main question, right? A main question. Like a main question, for example, like you can say like how were light bulbs formed, right? Then the question might be that so the title is how were light bulbs who invent why there are light bulbs? And oh no, wait, okay, I'm just saying this wait. I'm gonna say it all right because last time I said it all wrong, alright? So it's actually so pretend that the title is light bulbs, right? Then the main question should be who, like there's that, like you can think of many main questions, but I prefer that the main question should be why were light bulbs invented and why? So the main question for that topic, for the topic we're going to talk about, what is atomic mass and number, is how to calculate mass, number, and atomic number. So the first consequence is atoms are different. So atoms are different because they have different number of protons. No two elements have the same number of protons. So protons, like we say, like protons, electrons, all those stuff. So it's all about chemistry, basically, you can say. So like let me show you. Pretend my dot is the nucleus of an atom, right? So nucleuses are the center of an atom. It has neutrons and protons. But now we're going to talk about the topic how atoms are different, because they have different number of protons in their nucleus, which is the center of an atom. So for example, hydrogen has in its nucleus, hydrogen has one proton. I just want to say that I'm not saying that that a nucleus doesn't have neutrons. They have neutrons, but if you want to say that atoms are different, you should know by using protons in a nucleus. So there are one proton in a nucleus. Okay, wait, let me just give you an example, okay? So in hydrogen, right? So the nucleus, right? The center of the hydrogen atom. It has protons and neutrons, right? But now we're calculating protons. So in the hydrogen atom, it only has one proton. And in nitrogen, it has seven protons. That means in nitrogen, it has 7 protons of the nucleus. So that means it shows that it's different. And it's leading to our second topic. What is atomic number? So the meaning of atomic number is the total number of protons present in the nucleus of any atom. Atomic number is represented by Z. So hydrogen, I talked about, right? Hydrogen. So hydrogen has only one proton in its nucleus. So that means its atomic number is 1. And just to tell you, it is represented by Z. And in nitrogen, its nucleus in its proton and its nucleus is 7. So the atomic number of nitrogen is 7. Now 2 more examples. Na or sodium, right? So sodium has 11 protons in its nucleus. So that means its atomic number is Z, representation of atomic number, or Z, and Z equals to 11 in sodium. So the final example for 2 is oxygen. So in oxygen's nucleus, there is 8 protons. So its atomic number is 8. So number 3 we're going to talk about is atomic mass or mass number. Its meaning is the sum of total number of protons and neutrons present in the nucleus. So the representation of atomic mass is represented by A. So the first atom we're going to talk about is He, or helium. So in its nucleus we're doing, okay? So in its nucleus, they have helium has 2 protons and 2 neutrons. So 2 protons plus 2 neutrons equals to 4 units. So that means its atomic mass is 4 units, you can basically say. So remember always, protons plus neutrons equals to units. And so the second atom we're going to do is carbon. So carbon has 6 protons and 6 neutrons in its nucleus. 6 protons and 6 nucleus. So 6 plus 6, it equals to 12. So its nucleus, so the atomic mass of carbon is 12. 1, 2, 12. And the final example is kind of hard, okay? So Na or sodium. The last item we were talking about in had the atomic number of 11. Na. So in its nucleus, it has 11 protons and 12 neutrons. And it equals to 23 units. And I just want to say something. Every proton and neutron does not have the same number. Sometimes protons can be higher than neutrons in an atom, but sometimes neutrons can be higher than protons in an atom. So it can mix match. I meant to say protons to neutron. Proton is more than neutron sometimes, and neutrons is more than protons. I meant to say like that, okay? So the same thing I want you to remember, okay? So the mass number equals to number of protons plus number of neutrons, and it equals to the units, or the atomic mass. So the fourth thing is why we ignore the mass of an electron. So there are 3 things: electron, protons, and neutrons. And why do we always say good job to the masses of protons and neutrons? Why? Why we don't respect electrons? Because we consider the mass of electron is negligible. That means it is too small. That means the mass of an electron is too small to calculate. So that's why the perfect things are neutrons and protons. So the fifth, the thing I told you before, right? The negligible part, why electrons are not there. So it is. It is a 4 part question. Part 4, I mean. So the last part, or part 5, is symbolic representation. So its mass number is represented as A, and its atomic number is represented by Z. So you can use an X. So on the top of the X, there's A, and on the bottom of the X is Z. So for example, when you make a square, right? Always the atomic so that always the mass number should be up, which is 80. For example, we can use the atom frames here, right? So 87 is its mass number, and its atomic number is 223. So A is mass number, and Z is atomic number. So A to Z. Now we're going to talk about something else. Now we're going to talk about the moon wavewatch. The discovery, so the moon of Quaoar is Quaoar. So the discovery of the moon is February 14, 2006. And who discovered Quaoar? So the discovery who made by Quaoar is Hubble Space Telescope. Its moon size is 170 kilometers, or 105 miles. And its moon's radius is 85 kilometers, or 52 miles. That'll take like 2 to 3 hours for a person to drive on the whole moon, in estimate. So remember, I told you like diameter and radius. So it's no wait. Yeah, diameter and radius. So its moon size or diameter is 170 kilometers, and its moon's radius is 85 kilometers. So radius is half the size of diameter. This is very interesting, but it's dim, and it's a very interesting question. So is it dim? Yes, or no? Yes, and the answer is yes. It is very dim. Now, in a question in the question I'm going to tell you now is what is the meaning of dim? So the meaning of dim is you cannot see well with your own eyes. So you cannot see the object with your own eyes. Only you can see with very powerful telescopes such as the Hubble Space Telescope and the James Webb telescopes. Its magnitude, and now we're leading to another part of question 7. And going to question 8. So its magnitude is plus 24.7. So the question 8 is what is magnitude? So the meaning of the meaning of magnitude is is an object that has so it's an object that is wait, okay. I'm just having confusion with something. So if an object is dim, it has a magnitude of plus. But if an object is not dim, it has a magnitude of minus. So its magnitude is a plus 24.7. The plus shows us that it is dim. That's why I said yes. Excuse me. Wait. I just want. So the discovery of Quaoar is actually a surprising discovery. Do you know why? Because so it was discovered by also Michael Brown, the discoverer of Quaoar. So now we're talking about Quaoar, right? He also discovered Quaoar, and he also discovered Quaoar, which is very surprising. And also, there was a woman who discovered with him. Her name was Terry Ann Sewer. So I'm gonna say this one more time. So it was discovered in February 14th, 2006, by using Hubble images. So the moon was named after the Tongva sky god instead of Quaoar. Tongva. So Tongva means it's like Tonga. Tonga is like a country in the Pacific. It's an island country. So the tongue sky god, which is Quaoar. And it said, and the father of Quaoar is Quaoar, and that means Quaoar is also a god too. You can basically say. So where was the name announced? It was announced by the NPC, Minor Planet Center, in a notice published on what year? On the year of October 4th, 2000. On October 4th, 2009. So it rotates on an average distance of 13,330 kilometers, or 8,300 miles. So now we're going to talk about how much days does Quaoar orbit in one rotation. It rotates pretty long. It rotates in 12 days around Quaoar. Now, the fraction size we're going to talk about now is very important. So the fraction size of Quaoar is a 1/6 or 1/7 size of Quaoar. That means Quaoar is smaller than Quaoar. Quaoar is like Quaoar is that big, and Quaoar is like 1/6 or 1/7 of it. That means like if you were to cut 6 to 7 equal parts of Quaoar, the size of you can see the size of Quaoar. Now, leading to question 9, or the last question. No, I'm not saying numbers. I'm very sorry. So now, leading to the last question. The temperature is 230 degrees Celsius, or minus 382 degrees Fahrenheit. So, my bad, okay? Now the question is how to calculate Celsius to Fahrenheit and Fahrenheit to Celsius. So I'm going to tell you the formula now. So number 1 is, so the thing we're going to talk about first is Celsius to Fahrenheit. So Fahrenheit, so Celsius to Fahrenheit, right? So Fahrenheit equals to 9 divided by 5, which is 1.8 times the number of Celsius, and plus it by 32. That'll give you your answer. Celsius to Fahrenheit. And now, Fahrenheit to Celsius. So for Celsius, it's a little bit hard. So for example, so the Fahrenheit minus 32, and then you have to times it by 5. And after you did all those, I told you, like in Fahrenheit to Celsius, divide the whole thing by 9. So this is a formula, which means it'll give you your perfect answer. So now a mini part of the main question is an example for Celsius to Fahrenheit. So in a matter of fact, what if I say 35 degrees Celsius, right? Celsius to Fahrenheit, 35 degrees Celsius, right? So now you have to times so you have to do 9 divided by 5, which equals to 1.8, and then you have to times it by 35. The answer will be 63. 1.8 times 35, and then you have to times it by 60. You have to plus it by 32. So 63 plus 32 equals to 95. So 35 Celsius equals to 95 degrees Fahrenheit. You may think it's cold, but it's actually very hot. So the third mini part of the question is an example for Fahrenheit to Celsius. Now let's say 50 degrees Fahrenheit. So now let's do Celsius, okay? Now we have to do 50 divided by 50 minus 32, which equals to 18. And you have to times it by 5, which equals to 90. And then you have to divide the whole thing by 9, and which equals to 10 degrees Celsius. So basically you can say 50 degrees Fahrenheit equals to 10 degrees Celsius. So our work is done. I'm very happy that our work is done. So someone asked me a question, right? How is the Earth formed? So next time I'm gonna answer that. And someone asked me that question, right? So it's okay. Feel free to ask me questions. I can give you like knowledge. But first I have to research about it. So take some time, okay? See you later, everybody. Bye bye. And stay healthy and be kind.